Hi everyone, welcome to another math session with the Polymath. I start by apologizing that I have some common colds and my voice could not be very clear today, but I hope I'm audible enough. Now in today's session, we are going to learn working with metric units. As you can see the title here, metric units. Now I start by defining units, or in other words, a unit. What is a unit? So a unit is a standard quantity that is used to measure physical quantities. Now, for example, let's assume you are measuring the length from A to B. Now, this is point A. Here we have point B. And then this is the length between the 2 points, A and B. Let's assume this is 1 meter. Meter is a unit that is used now to measure length. And now if we have another point, for example, from point C to point D, this could be 2 meters, which means this length is twice this standard length here. So a meter is a standard length between two lines, for example, the line A and B, which tells us the distance here. And then we can now use this standard length to quantify other lengths, as you can see, like the length from C to D, which is 2 meters, meaning it's twice the length from A to B, or having a length X and Y, 2 points X and Y. So point Y is here. Now this length is half the standard length AB. So you can say that this is half a meter. Now units are standard quantities that are used to measure physical quantities. Physical quantities include length, mass, temperature, density, electric current, amount of substance, and many more. For example, saying 5 is just a number. I just mentioned 5, but saying 5 meters tells you how long maybe something is, or saying 5 kilogram tells you how heavy something is. Now meter here is a unit, kilogram is a unit, but the 5 here is just a number. This leaves an ambiguous case because we don't know really what 5 is representing. Now here, meters and kilograms are the unit, and 5, they make 5 to make sense. So you can see this one here doesn't make a lot of sense because it's just a number. We don't know 5 what. Now, without unit, for example, I say 4.24. This one remains ambiguous because you don't know if something is 4.24 long. We do not know how long it is. Now, it could be 4.2, maybe light years, like the distance from the Sun to the Proxima Centauri, which is the closest star to the Sun. I mean the second nearest star to the Earth, because the Sun is the closest star to the Earth. Now, the distance from the Sun to Proxima Centauri is 4.24 light years, which means light take 4.2 years to travel from Sun to reach Proxima Centauri, which is a member of Alpha Centauri system. But if I say maybe 4.24 meters, this is a very short distance. Maybe the length of a van, a school van, could be roughly 4.24 meters, or a personal car. Now, we need this unit to make the number make sense. Without the unit, it remains ambiguous, like you can see 5 here. Now, for example, I ran 10. Let me write here, I ran 10. You can't say, you can't tell 10 what. I mean, this one doesn't make sense because you're not sure whether I ran 10 meters, 10 kilometers, or even I ran for 10 minutes, where a minute is now a unit of time. Maybe I ran for 10 minutes, or I ran 10 meters, or I ran 10 miles. So we can say that units make quantities clear, comparable and useful. If I say I ran for 10 minutes, this one makes more sense than the first case here, which is ambiguous. Or if I say I ran 10 meters, 10 meters. This is a very short distance, maybe from the one side of the room to the door. It could be around 10 meters, depending on the size of your room. Or I ran 10 kilometers, depending on the units. Now, metric units are units of measurement based on metric system. Metric system is a keyword here because we have several other systems, but we are focusing on metric system. At the end of the lesson, we shall check how to convert maybe between metric system and some other commonly used systems of units. Now, the metric system is a decimal-based system, which means powers of 10. So we can have 10 raised to power 1. These are integral powers of 10, meaning that the powers should be whole numbers, be 10 raised to power 2, 10 raised to power 3. We can now have multiples of 3, for example, 10 raised to power 6, 10 raised to power 9, and so on. Now, the base here, decimal-based system, means 10 is the base, as you can see. And then this is an integral. This is an integral power of 10, meaning an integer. Of course, we can have even the negative powers. For example, 10 raised to power negative 1, 10 raised to power negative 2, 10 raised to power negative 3, 10 raised to power negative 6, and so on. Now, they are used to measure quantities like length, which are the fundamental quantities, length, mass, time, or even their derived quantities such as volume and density. You can see volume, temperature is a fundamental quantity. Now, they are standardized, easy to convert, and are widely used globally, especially in science and most countries. Now, base 10 unit have this characteristic, like each unit is 10 times bigger or smaller than the next. For example, we've compared here, we have 10 power 1 and 10 power 2. 10 power 2 means this number here is 10 times bigger than the previous number. If you have 10 power 1, you multiply by 10. It's 10 times bigger. 10 is basically 10 power 1. You can check from our previous session working with indices that this one turns out to be 10 power 1 plus 1, which is 10 power 2, as you can see here. Now, comparing these two, 10 power 1 and 10 power 2, you can say that 10 power 2 is 10 times bigger than this one, than 10 power 1. Also, they have a prefix which indicate the size. Now, a prefix and a base unit gives a specific measurement. Now, a base unit could be meter, as we discussed earlier on, where we had the length here. But you can change. For example, I ran 10 kilometers. Now, this one is a prefix, meaning something that is fixed prior to the unit, and meter now is the base unit. Now, a prefix is something that is fixed prior or pre, not post. It's fixed prior to the base unit. Now, this one has a factor. For example, K has a factor of 10 raised to power 3. And now we can substitute this K here with its factor to have our new sentence becomes I ran 10. We are multiplying with k, which is times 10 power 3 meters. Now, meters is the base unit. This was the prefix. But now we've substituted the prefix with its factor here. That's why now we have I ren. This is 10,000 meters. And we all know that 10,000 meters is equivalent to 10 kilometers. Now let's check more about the prefixes that are used. Okay, here we have the name and the symbol. The symbol is very, very important. I start by highlighting that you can see from here all the way to this point. These are uppercase letters, but from K for kilo, this is a lowercase or a small letter. Also, we have deca here, which is very special because it's the only symbol that has two letters to represent it. Comparing to all other symbols here, they have one letter, either uppercase or a lowercase letter. Now, we have the unit. This is where we have the base unit. The base unit. You can check the yellow box here. Let's assume we are measuring length. And we agreed a few minutes ago that the base unit of length is a meter. Now this is the base unit. Now this is the symbol here. We know that the symbol of meter is M. You can write M here. And also it's 1 because we said a unit is a standard that is used to measure other physical quantities. It's a standard quantity that is used to measure other physical quantities. Now, since it's standard, it must be 1. Now, these are just the common names. You can write common here to distinguish from this one. So this is the scientific name. We have the symbol and the factor here. This is the common unit. The common name. Now, let's assume the unit is meter, the base unit. For the case of length, okay, if we have 10 times that standard quantity, that standard length that we called a meter, if we have 10 times, which now makes the new length 10 meters, then it means it's 1 times 10 power 1 or 1 times 10 meters. And if we have 1 times 10 power 1 meters, we can now replace this factor by its symbol, which is dA. It's called deca. Now our new length becomes 1 decameter because now decameter is equivalent to 10 meters. Now, as you can see here, we have powers from 0 and they are all integers. 0, 1, 2, 3. Here they are advancing in ones. But from mega here, from 10 raised to power 3, we have now powers which are multiples of 3. For example, 10 raised to power 6, 10 raised to power 9, 10 raised to power 12, power 15, so on and so forth. Also, we have there submultiples, which are now the negative powers, which we tell you to divide. 10 power negative 1, 10 power negative 2, 10 raised to power negative 3, and then multiples of 3. So 10 raised to power negative 6, 10 raised to power negative 9, 10 raised to power negative 12, 10 raised to power negative 15. This is very small, maybe the size of a proton, which is 1.7 femtometer, meaning 1.7 times 10 power negative 15 meters. Because now F is the symbol for this. This is the factor for femto, but the symbol for femto is F. The base unit remains metered, so the length is still measured in meters here. As you can see, if we replace f with its factor, which is 10 power negative 15, this is relatively small. Nano 10 power negative 9, for example, the wavelength of visible light, which ranges from around 400 nanometer to 700. We have the length of 1 meter, the size of a child or an adult could range 1.7 to roughly less than 2 meters. So it's in the order of magnitude here. Maybe 10 power 6, 10 power 5, 10 power, all those powers you can see. Now, 10 power 1 is just 10. This is the common name, 100, 1,000, a million. But now the scientific name is decta, hecto, kilo, mega, giga, tera, and so on. Now, you need to familiarize yourself with this. We have 10 to power 0 all the way to 10 power 30. And on the other side, we have 10 to power 0 all the way to negative 30. Now, let's do a few examples here to enhance our comprehension of the same. For example, the distance to the nearest star is about 3.99 times 10 raised to power 13 kilometers. You're required to convert this one into millimeters. Now, let's have solution here. And I start by making it clear that to remove a prefix, you multiply by its factor. Also, to introduce a prefix, you divide by its factor. Now, this is the distance to the nearest star. And we said the nearest star, we already mentioned it, is 3.99 times 10 power 13, which is the Proxima Centauri. Now, we are required to convert this into millimeters. You can see the prefix here is K. We need to remove this K and introduce our new prefix, which is M. Now, back to our data sheet. You remember that K is 10 to power 3, which is kilo. M is milli, which is 10 power negative 3. I'll just go back and we have to check them here. Kilo is 10 raised to power 3, and milli, which is M, which is now the new prefix that we want in our measurement, is 10 raised to power negative 3. Now, we need to remove this one first, and we have some short notes here that removing, we need to multiply by its factor. You just substitute K with its factor so that we can get rid of it. Now, 3.99 times 10 power 13. K, because I want to remove it, I will multiply by its factor, which is 10 power 3. And now the measurement is just in base unit. This is now measured by the standard quantity that we said it's a unit. Remember, a unit is a standard quantity used to measure other physical quantity. Now, this one doesn't have prefix any longer because we have already substituted k with its factor here. Now, from our previous lesson, we discussed how to work out the indices. This is the coefficient 3.99 multiplied by 10 power 13 multiplied by 10 power 3. Now, if I'm working this one, these are the indices now we discussed during the previous lesson. I've attached the link for the link for the indices here. If you have not yet watched the video, you can check it. This is the coefficient. You can see it's just a number. It doesn't have a base or some power, some sort of power. But for this one, we have the exponent here, which is 13, and we have the base. If they have common base, we just need to add these powers. And now, this one turns out to be 3.99 times this part here would be 10, 13 plus 3 raised to power 13 plus 3 meters, which is 3.99 times 10 raised to power 16 meters. Now, our measurement is already in base unit. There is no prefix here. But the question requires us to insert a prefix. You can see M, pre, meaning M is appearing before now the unit here. So we have M for milli, which is the symbol for milli. Milli has a factor of 10 raised to power negative 3. But the base unit of length is meters. Excuse me. Now, to introduce a prefix, you divide. To introduce a prefix, you divide by its factor. Now, the factor of M is 10 power negative 3. You have to divide by 10 power negative 3. Now, this one turns out to be 3.99 times 10 power 16. We divide it by 10 power negative 3. But we have already now inserted our prefix here, which is milli, and then the base unit was meters. Now let's work out the indices here, which is in form of a fraction. 10 power 16 divide 10 power negative 3 results to 10 power 16 minus negative 3, which is 10 power negative 19. And now our solution is 3.99 times 10 power 19. We already inserted milli, then the unit was measured in meters. The quantity was measured. The base unit of the quantity is meters here, as you can see. Now this is the solution, and we just basically remove by multiplying or substituting the symbol with its factor. And the operation we have to carry out is multiplication. And to introduce now a prefix after we have removed it and we want to put in another different prefix, then we have to divide by the factor of that prefix. Now, a distance of 3.99 times 10 raised to power 13 kilometers is equivalent to 3.99 times 10 raised to power 19 millimeters. Now, a second question, the human hair is about 50 micrometers in diameter. How many kilometers is this diameter? So the steps are simple. The solution. First, you need to remove this micro here. Micro. Remember the symbol of micro is mu. And then the base unit is meters. So this is micrometer. We need to remove this one, the micro here where my pen is hovering. and we remove by multiplying by the factor. Remember, micro had a factor of 10 raised to power negative 6. Now, we have 50 mu, 50 micrometers, or let me go step by step. 50 micrometers is 50. We substitute the mu with its prefix, 10 power negative 6. Then m remains, meters. And then how many kilometers is this diameter? We have to change this one now into kilometers. We need to introduce, this one doesn't possess any prefix. The quantity here, which is the diameter or the length, is just measured in the base unit of length, which is meter. Now we need to introduce k, and we introduce by division, carrying out the division operation. Now this becomes 50 times 10 power negative 6 divided by 10. Now k is 10 power 3. We are dividing by the factor of whatever we want to introduce, kilo. As you can see here from the question, is 10 power 3. And now dividing again, if they have the same base, we just need to subtract the indices. You subtract the index of the denominator from that of the numerator. So we have 50 times 10 raised to power negative 6. Then we subtract 3, which turns out to be 50 times 10 raised to power negative 9. We already introduced the prefix, which is k, and the base was m for meters. So this is the solution. Okay, example 3. The surface area of the earth is about 5.1 times 10 raised to power 8 kilometers square. 30% of this is covered by land. How many millimeters square of the area covered by water are there? Now, the surface area is 100%, which is equivalent to 5.1 times 10 raised to power 8 square kilometer. Now, the area that is covered by water is 70%. This is a fun fact that I'm learning today, that the area covered by water is larger, more than twice the area covered by land. Now, 100% minus 30% gives 70%. This is the area covered by water. Percentage, by definition, is a fraction whose denominator is 100. Now 70% is 70 upon 100. Now we multiply by 5.1 times 10 raised to power 8 square kilometer to get 3.57 times 10 raised to power 8 square kilometer. Now this is the area that is covered by water, and now we need to convert this one into millimeters, as the question tells us here. Now we need a conversion factor. Area is a second order degree unit, and from our data sheet we only have units. I mean, we only have linear units. Now we have to draw a square here. So that we can get a conversion factor to convert from square kilometer to square millimeters. Now, let's make the side length here be 1 kilometer. And we have 1 kilometer here. Now, 1 kilometer is equivalent to how many millimeters? We have 1 kilometer. We need to remove this prefix here, the k. We remove by substituting prefix, the symbol of the prefix by its factor. Now this is 1 times 10 raised to power 3 for kilo, then meter, which is 1000 meters. Now we need to introduce a prefix here, millimeter, milli, the prefix milli, so that our unit becomes, our measurement now becomes millimeter. We introduce by division, and remember that from our data sheet, milli is represented by m, small letter m, and is equivalent to 10 raised to power negative 3. Now we are dividing by this. We have 1000. We divide by 10 raised to power negative 3. By doing that, we'll have introduced milli, and the base unit remains meters. Therefore, this is 1000. Dividing is the same as multiplying by the reciprocal here. So we multiply by 10 power 3. Now I have used indices. I emphasize, if you've not watched the video on indices, you need to watch so that you get familiar with working with indices. For example, if we have 1 over maybe any number raised to power negative n, now we can get the reciprocal here, and then the index becomes positive. So this is equivalent to this way. Now that's why now I replaced, I changed the sign of the index here, which was negative, to positive, and then I did the reciprocal, because the reciprocal of this now becomes a power negative n. But now we have to change the sign of the index, which becomes 10 raised to power 3. Now this becomes 1000 times 1000, which is 10 raised to power 6 millimeters. Now this length is equivalent to this one, which is 1 kilometer, which is 10 power 6 millimeters. Same case to the other one, 10 raised to power 6 millimeters. Now let's find the area of this square. The area is 1 kilometer multiplied by 1 kilometer, length times width, or length squared, which gives 1 square kilometer. The same square has an area of 10 power 6 millimeters multiplied by 10 power 6 millimeters. 10 raised to power 6 is equivalent to 1 kilometer. Therefore, the area must be the same, because we are just finding the area. We are finding the area of the same square here, which is 10 power 12 square millimeter. And now this is our new conversion factor, where 1 kilometer squared is equivalent to 10 raised to power 12 millimeters squared. So we can use this conversion factor here to work out the area of the earth that is covered by water into square millimeters. Now we found the area is this number here, 3.57 times 10 raised to power 8 square kilometers. Now let's convert. Our conversion factor states that 1 square kilometer is equivalent to 10 raised to power 12 square millimeters. What about 3.57 times 10 raised to power 8 square kilometers? How many square millimeters are they? Because multiply. Now this one becomes 3.57 times 10 raised to power 8 times 10 raised to power 12 divided by 1. So the answer is 3.57 times 10 raised to power 8 plus 12, which is 20 square millimeters. Example 4. The volume of the earth is approximately 1.08 times 10 raised to power 27 cubic centimeters. Express this in cubic kilometers. Now, centimeters and kilometers are units of the first degree. Maybe if we define area as the measure of surface, then the units of area are two dimension. It means they are the units of the second degree. Now the units of the volume are of the third degree. And from our data sheet, whatever prefixes and multiples or submultiples of those prefixes, the factors that were given are linear, meaning of the first order or the first degree. Now we need here to find a conversion factor which will enable us to work the units from centimeter cubic to kilometer cubic, which are now the units of the third degree. Now solution. I'll start by a small sketch. I'm not good at drawing, but I'm trying to find something that can illustrate clearly. Now this is a cube of side length 1 centimeter. The width is 1 centimeter and the height is 1 centimeter. Now the volume of this cube is given by length times width times height, which is 1 cubic centimeter. Now I want to express this length, the width and the height in terms of kilometers now, which are linear or units of the first degree. Now I have 1 centimeter here and I have to remove this prefix first before I can introduce K, which is the prefix in which we need our length. Now to remove a prefix, we substitute the symbol of that prefix with its factor. This means 1 times 10 power negative 2. Now 10 power negative 2 substitute C, but the base unit remains as meters because we are measuring the length. Now we already have the length here, which is 1 times 10 power negative 2 meters. And now we need to introduce our new unit, which is our new prefix, which is K. Now we have 1 times 10 raised to power negative 2, and introducing means division by the factor of that prefix that we need, which is 10 power 3. Now division tells us to subtract the indices. So we have 1 times 10 raised to power negative 2, and then we subtract 3. Now this turns out to be 1 times 10 raised to power negative 5. But remember, we already introduced. By this division means we've introduced the prefix, which is K. And now the new length is 5 times 10 power negative 5 kilometers. Now I can have the measurement here as well. This length here corresponds to this length, which is 10 power negative 5 kilometer. Then the width here corresponds to this width, And now the width here can be expressed in kilometers. Remember the width of the cube are equal. So this one is 10 raised to power negative 5 kilometers. And the height, 1, 2, 3. Now the height here, which is in centimeters, is the same as this height, but I want to write it here. So this one is 10 raised to power negative 5 kilometer. Now the volume can as well be found by now the kilometer unit, which means multiplying. And from our last session on indices, we said if we have to multiply three numbers which are similar, 10 raised to power negative 5 times 10 raised to power negative 5 times 10 raised to power negative 5 is just to cube this one, and we have to multiply the powers, which gives us 10 raised to power negative 15 cubic kilometers. Now, this volume is basically the same here because we have the same cube. The cube has not changed. It occupies the same space. And now the volume is the same, whether it's stated in cubic centimeters or stated in cubic kilometers. The value remains the same. Now, this is our new conversion factor, that 1 cubic centimeter is equivalent to 10 raised to power negative 15 cubic kilometers. And now we have the volume of the earth, which is stated here as 1.08 times 10 raised to power 27. We need now to convert, and we are using this conversion factor here. Now, we can say that 1 cubic centimeter is equivalent to 10 raised to power negative 15 cubic kilometers. Now, what about 1.08 times 10 raised to power 27 centimeter cubic? How many kilometer cubic are they? We need now to cross multiply here. Yeah, which leads to 1.08 times 10 power 27 cubic centimeters multiplied by 10 raised to power negative 15 cubic kilometers, and then we divide by 1 cubic centimeter. Now this unit here will cancel out, and now we are left with 1.08 times 10 power 27 times 10 raised to power negative 15, which brings us now to addition of these indices here. And if we add the negative number, which is subtraction, we get 1.08 times 10 raised to power 12 cubic kilometer. Now, when you have your units in linear form, for example, the units of length are linear, the units of area are of second degree, and the units of volume are of the third degree, then you need to find a conversion factor first, but you still use the same data sheet that we talked about a few minutes ago. Now we have conversions between metric units and other units. We have some other units like yards, miles, maybe architectural inches, which are not metric unit, or they don't advance by the multiples of 10. As we found, the metric units are easier to convert because every unit is greater than the previous unit by a factor of 10. Now let's take this example here. The latest estimate of the Great Wall of China is 13,171 miles. Convert this into kilometers. Now we are given that 1 mile is equivalent to 1,760 yards, and 1 yard is equivalent to 36 inches, and 1 inch is equivalent to 2.54 centimeters. Now, all these units are linear. we are just dealing with the first degree units. Now, let's start by converting these miles into yards. We have 1 mile solution. 1 mile is equivalent to 1,760 yards. Now, what about the wall, which is 13,171 miles? How many yards are they? You cross multiply. Now we have 13,171 multiplied by 1,760, which yields 23,180,960 yards. Now, again, 1 yard is equivalent to 36 inches. What about 23,180,960? How many inches are they? So we are just required to multiply 23,180,960 multiplied by 36, which yields 834,514,560 inches. Now, we are further required to convert these inches into centimeters, and we have a conversion factor here that 1 inch is equivalent to 2.54. What about this number of inches here? How many centimeters are they? So this one is 834,514,560 multiplied by 2.54, which yields 2,119,666,982 centimeters. And now, 1 centimeter is equivalent to how many meters? This is now a metric unit. It has a prefix here that we need to remove by substituting the prefix with its factor. So this one is equivalent to 1 times 10 raised to power negative 2 meters. And now, the answer was required in kilometer. As you can see here, we need to introduce K in our unit. Now, this one doesn't have any prefix now because we've already substituted the factor of C, but we need to introduce K. And by introduction means division, which is 1 times 10 raised to power negative 2 divided by 10 power 3. So we subtract the indices, 1 times 10 raised to power negative 2. We subtract 3, which turns out to be 10 power negative 5 kilometer. And now the length, this value here, that was in centimeters, can be converted into kilometer by multiplying by 10 power negative 5. So the answer here becomes 2,119,666,982 times 10 raised to power negative 5. Now the solution is already in kilometer. I can leave the answer in two decimal places as 21,196.66 kilometers. And now I can write this in standard form. If you have a problem in standard form, you remember to watch the video on significant figures in standard form. So I'll take this decimal point 4 steps to the left up to this one. So the new answer becomes 2. I can write in three significant figures, which is 2.12 times 10. I took it to the left 4 times, 4 steps. So times 10 power 4, but the unit was kilometers. Example 2, Burj Khalifa skyscraper in Dubai is 829.8 meters in height. How high is this in feet? Now 1 foot is equivalent to 12 inches. And previously we found that 1 inch is 2.54 centimeters. Remember that 1 yard was equivalent to 36 inches, which tells us that 1 yard is equivalent to 3 feet. Because 1 foot is 12 inches, now 3 feet will be 36 inches. So 1 yard is 3 feet. Though we are not using this for now, just leave it, and we now have the solution here. Now we have these meters, we need to convert them into centimeters, and it's by introducing. So we have 8.829.8 meters. We need to convert them into centimeters by introducing a prefix here, which is C. We said introduction means division, so we have to divide by the factor of C. And remember from our data sheet that C is 10 raised to power negative 2. Now we have the coefficient, which is 829.8, and now we are dividing. Dividing is the same as multiplying by the reciprocal. We are dividing by 10 power negative 2, which means multiply by the reciprocal, which is 1 over 10 power negative 2. Now from the laws of indices, you remember we found this, I can write it here, that any number raised to a negative power is the same digits written as reciprocal, but now the power turns to be a positive. Or even if the power was negative, then it's the same as a power n. You can see the digits are the same and they retain their positions even though they are now inverse. This a is the base, it remains the base here, n is the power and remains the power here. So the same digits are used, but the sign of the power changes. Here it was negative, as you can see, but it's positive here, or a negative and then positive. Now by using this, it tells us that 1 meter is equivalent to now 10 power 2 centimeters, because we've now introduced the prefix that we wanted to introduce. We introduced by division, as you can see here. Division is the same as multiplication of the reciprocal. But from indices, if the reciprocal has a negative, if the original number has a negative index, then the reciprocal will be positive. So this one tells us that 1 meter is equivalent to 100 centimeters. Now, what about 829.8 meters. How many centimeters are they? We do the cross multiplication as we've been doing. This turns out to be 829.8 meters multiplied by 10 power 2, which is 100 centimeters, and then divided by 1 meter. So the units of meter cancel out, and we are left with the solution now has 82,980 centimeters. Now, there's a conversion factor here for inches, that 1 inch is 2.54 centimeters. We need to divide this one by 2.54 to get the solution in inches, which turns out to be 32,669.29 inches. Now, 12 inches make 1 foot, as you can see from the conversion factor given here. Now we have 669.29 inches. We need to convert them into feet by dividing by 12. So we have 32,669.29 divided by 12, which is 2,722.44 feet, that we can write in standard form. Okay, our initial measurement here was measured to 4 significant figures, as you can see. So I prefer leaving my answer here in 4 significant figures, which becomes 2.722. But now I have to take the decimal place 3 times, the decimal point 3 times, or 3 places back. So times 10 raised to power 3 feet. Example 3. The length of the football pitch must be between 100 yards and 130 yards, and the width must be between 50 yards and 100 yards. Find the difference between the maximum and minimum area in hectares. Now we have some conversion factors here that we are supposed to use. And area is a unit of the second degree. So we also have to find conversion factors to change from the second maybe to the first degree, because we are dealing with length here. Now if we find the area, we have now to change it into hectares. Now solution, I start by sketching. We have the larger field or ladder pitch, and then there is the smaller pitch, which is smaller in width, and also the length is relatively smaller compared to the larger one. Now the length of the larger pitch must be 130 yards, 130 yards, and the other one must be 100 yards. Now the width must be between 50 yards and 100 yards. So 50 yards must be the smaller pitch, this one, which is 50 yards. This one is 100 yards, the larger pitch. Now, since we have the first conversion factor here, that 1 yard is equivalent to 914.4 millimeters, we have to change them into millimeters first. Now if 1 yard is equivalent to 914.4 millimeters. As you can see here, 914.4. What about 100 yards or maybe 130 yards? Let's start with this side length of the larger pitch. 130 yards are equivalent to how many millimeters? We have to cross multiply. So 130 yards times 914. 914.4 millimeters divided by 1 yard. So yes, cancel out, you're left with 130 multiplied by 914.4. Now, this one becomes 118,872 millimeters. If you convert the 100 here, you get 91,440 millimeters. 50 yards, of course, it must be half of this, half of 91,000, which is 45,720 millimeters. And 100 yards is, of course, what we had here for 100 yards, which is 91,440 millimeters. Now we need to find the area of the larger pitch. Area is given by length multiplied by width. Let's find the area in millimeters, which is 118,872 multiplied by 91,440. This one gives 10,869,655,680 square millimeters. And then now the area of the smaller pitch, it's still the product of length and width, which is 91,440 millimeters multiplied by 45,720 millimeters. This becomes 4,180,636,800 square millimeters. Now, I prefer to work out the difference here before I convert to other units where I have to convert this one, convert the area of the smaller one, and then get the difference. So it's better I get the difference here early enough, then I can convert later. So to get the difference between the areas of the pitch, I have to subtract the area of the smaller pitch from the area of the larger pitch. So the area difference is given by 10,869,655,680. We subtract 4,180,636,800 square millimeter. And then the difference is 6,689,018,880 square millimeters. Now, let's convert these square millimeters into square meters so that we can get the required area into hectares. Now I have a square here as we did in the third question. This seems like a rectangle, but let's assume it's a square and all sides are equal. Now, this side length is 1 meter. This is 1 meter. But we can now have 1 meter converted into millimeters by introducing a prefix here. We introduce by division, which means we divide 1 meter divide by the factor of this prefix here, millimeters. Milli. Milli means 10 power negative 3. Using the laws of indices, this is the reciprocal, and we have 10 power 3. We've now introduced the prefix because we've already divided by the factor here, and the base unit remains meters. Now, this is equivalent to 10 power 3 millimeters and 10 raised to power 3 millimeters. Now, the area of this square must remain the same if you multiply length and width for whichever side that you take. Now, I have 1 meter multiplied by 1 meter. It gives the area as 1 square meter, and this is equivalent to 10 raised to power 3 multiplied by 10 raised to power 3, which is 10 raised to power 3 plus 3, which is 10 raised to power 6 square millimeters. Now this is the conversion factor, but we have our area here, this one, which is in millimeter square, and we have to change it into square meters. So we have to take this area and divide by 10 power 6, which means we move the decimal point 6 steps or 6 places to the left by division. So the answer here is left at 6,000. You can write area in square meters 6,689.01880 square meters. Now, I already have the area in square meters and I have to change it into hectares. Let's check the conversion factor where 1 hectare is equivalent to 10,000 square meters. It's given in the question here. 1 hectare is equivalent to 10 raised to power 4. Now I have the area difference in square meters, which is 6,000, and I have to change it into hectares by dividing by 10 raised to power 4. So I have to take 6,689. I can just use 4 significant figures. The decimal point appears at this place, 0.0, then divide by 10 power 4, which tells us still to take decimal place on the left further from this point, 4 steps, which becomes 2, 3, 4, 0.6689 hectares.